In this video, I'm going to demonstrate the egg hunting attack. We are going to attack our VChat program again, but we are going to attack a different command. So in this command, there is a variable function. Here is the stack frame for that function. So we can see here, right below return address, we have only 144 bytes of space. Above return address, we have 32 bytes of space. And the main string will do this. So it's going to overflow the buffer here, and we are going to overwrite the return address with the address of a jump ESP instruction, so that when the function returns, it's going to run jump ESP, then it's going to run the instruction just above this return address. And so we actually put a jump instruction above the return address so that the execution will jump to the start of the buffer, roughly start of the buffer. And because you can see here, this space is too small, right? We can put some kind of a code called Egghunter here. And what the Egghunter does is it's going to search the program space for a particular pattern. And so we are going to use another collection and inject that pattern and malicious code into the program space. So once the Egghunter finds the pattern, it's going to run our malicious code. So that's the whole story here. Okay, so here you can see it's our Windows VM, and this is our caddy VM. Okay, and let me close here. And so we have all the things we already put here. Good. So let's go through this tutorial. So the first step is information connecting, right? And so what we are going to do is we are going to do this. So we are going to actually start the VChat program. Okay, and then we are going to use a telnet to connect to VChat. So we can use the help command to show all the commands available within the VChat program. Then you can see we have a GTER command here. Right, so that's what we are doing. Okay, and so we are now done with step one, information connecting. So now let's move to step two here. The step two is we are going to launch VChat using a muted debugger. So this is how we actually do it, right? I already have this shortcut here, but you can use open to open VChat. Remember, click the running button here. And then let's move to next step. So next step is a fuzzing. Okay, so we want to see what kind of data can crash, this GTER command. Okay, so we come to here, and so I want to open my fuzzing script. So it's within this tutorial. Okay, and so you can see here, right? And this is the fuzzing script And so here we specify the host, port, loggers, which will log this fuzzing session. Then we create the session, then we define uh, the messages. Right, so this is basically the request called GTER, and this is the template of the message. Right, it starts with GTER, then a space, then the data we are going to change, and character return. So then we specify session to use this request, and we start the fuzz. Okay, and so let me come to here. So I need to go to BooFuzz to start the fuzzing environment. Okay, then we go to tutorials and source code. Okay, so now we start Python, this BooFuzz fuzzing script. So now the fuzzing starts. Okay, let's see when it will crash. Okay, when it crashes, then I'll stop the fuzzing. Okay, and so now let's see here, right? And okay, and so here, let's see which message actually crashes VChat. It is this one, right? Something's missing here, and so we can see here %n. If we come back to here, so in this case, because I stopped very fast, then you can see here, basically this test case crashes VChat, 207 bytes of this weird stuff. Okay, and so now we know we can crash the GTER command. Now let's move on. And so we are going to do step 4. We want to find out size of padding to overflow the buffer. And so here we use this particular Ruby script to generate a unique cyclic pattern of data. And so here, let's see, 207, right? I'm going to just do that. Good. And copy it. Okay, so now I'm going to open Exploit1, replace data with our unique pattern of data. Okay, so here basically you can see here, right? So we just send this, message to WeChat, and the message starts with this one. I really don't think we need this, but anyway, we'll keep this. So let's have a look, see what happens, right? We want to find the size of padding, right, to overflow the buffer. And so here, let's restart this program, WeChat, right? Okay, so now we go ahead and run. explode one. Oh, something's wrong. Collection refill, what does that mean? Okay, so let me have a look what's wrong here. I didn't run this one. Yeah, I didn't run the program yet. Okay, so I need to run it. So now it should be okay. Okay, so we come to here and so something is wrong here. I need to restart. Okay, so let's redo it. So now I think it should be fine. Okay. It looks like we didn't overflow the buffer. That's weird. Let me see. Let me check again. So why it didn't overflow the buffer? So something's wrong. I shouldn't see this. And so let's restart, see what's going on here. Okay, let's run it. Let's do this one more time, see what's going on here. Okay, so now this time it works. I'm not sure why, but sometimes there are all kinds of issues here. And so you can see here, right? So this is a EIP when overflow occurs, and this is a part of our special data. And so 41356541, okay. And actually you can see the same thing here. And so I'm going to use this Ruby script to find out the offset of this. So 135. So we need actually 135 bytes of data and this part to overflow the buffer. Good. So now we find you know, the size of padding we need, right? And I think we shouldn't call this size of padding. It's size of maybe malicious string or something to overflow the buffer. Okay, so now we are done with the step what? 4. So we need to move on to find the address of jump ESP, right? As we mentioned, this is a trick we use to run the injector shellcode. And so we can actually do this here. Oh, sorry, not this one. We needed to use the Mona to do it. Okay, so you can see we find quite a few jump ESP instructions. We are going to use the first one. Okay, and so because this one is within this dynamic library, this dynamic library is used by VChat. Good. So now we are done with step 5. So next one is step 6. Okay, so as we mentioned, right? So basically, because you can see here, above return address, we only have 32 bytes of space. We don't have really much space to put a large malware code here. And so the trick we are using is we put a jump instruction here. It will jump to somewhere here, okay, after this GTER stuff. And so, however, we need to find out uh, the jump instruction. How can we find the binary code of a jump instruction? And so let me show you what we are going to do here. Okay, and so here, let's restart it. Right, it's running. And then in this case, we need to use export 3. Okay, so this is the export 3 script. So here is the main string. You can see we use GTER, then we use this padding, right, to overflow the buffer. Then we put a jump ESP here, which will overwrite return address. Okay, and so let's run this Python script. So this will be number 3. Good. So we can see here, something is wrong here again. Okay, let me restart it. Okay. So now let's run it. Good. Okay. So now you can see here, right? The buffer overflow occurs, and we have the padding of A's, and here is our, jump ESP address, right? And I want to set a breakpoint at the jump ESP address. How can we do that? So click here and put the jump ESP address here, and OK, and we right click on the instruction and set a breakpoint. Okay, and so now we are going to do this. Okay, so here jump here, we are going to rerun it. Okay, and let me see if it's still over there or not. Okay, still here. And but let's set up the breakpoint again. So it's not running yet, right? Okay, so now let's run. I need to redo everything here to give you a clear demo. And so I needed to come here and we redo it. Okay. So you can see here, we stopped here, right? And then what we are gonna do here. So we stopped here, that's breakpoint at this run. Then we do step over. So you can see now we are going to run this instruction. Of course, it's not really good, but you can see C corresponding to this instruction. And because we tell CPU to run the instruction at this location, it will explain the data here as instructions. And of course, we really cannot run it. What we try to do here is we want to put the jump instruction here. And to do that, so I click this location, then I actually will right click, assemble, right? So I'm going to put a jump instruction here, but then the problem is jump to where? So we want to jump to this A here. So that will be 00BC. Let me see here. I want to copy it. Okay, 0BCF921, right? And so now this is BCAC, right? BCF9AC here. Okay, F9AC here. Okay, and it's AE. So actually, this is where I want to put, right? And 62. So can we actually do this one here? AE here. I want to do AC. So why is like that? So why is no AC here? So I want to assemble. I want to jump to this location, right? But I want to assemble this one. Okay. AC. But there's something wrong here. I needed to change this a little bit. So let's restart and see what's going on here. Okay. Good. So then we jump, we step over, and we come to AC here. So I want to jump to this location. Okay, 00BC F921. Assemble, jump, 00BC F921. F921, good, good. So now it's good. Okay, and so you can see now right here, we add the code here. So now if I step over, right, it will run the instruction at 00BC F9AC. It will jump to this location. So now you can see we jump to this location. Okay, so that's how we find the binary code for the jump. Okay, and so we are done with this is step 6. We know what is the binary data for this jump instruction. So now we're going to do step 7 here, the Egghunter shellcode. And so the Egghunter shellcode can be created by this one, the Mona. So basically we go to Immune Debugger. So here is that Egghunter code. And so everything here is okay, right? And it doesn't change. And then, so we're going to create the shell code. We're going to create a band shell. And so this is the command to generate the band shell. So it's a server, right? And you can see, and so for the second connection, we're going to send, you know, uh, this actual malicious shellcode, waiting for users to connect, waiting for the attacker to connect. You can see at the start of the shell, we put the egg here, right? So basically, the Egghunter is going to find this egg, and then it's going to run the code here. Okay, good. So everything here is ready, and so you can see here. So basically, in step 9, we first send the malicious shellcode, so which is basically a backdoor over there waiting for the attacker to connect. Then we send the Egghunter malicious string, which will overflow the buffer. Then the Egghunter code will run. Okay, so this is our final code. Right, so I explained everything. Now let's see if it works or not. Okay, so I'm going to start the VChat program. Okay, and we're going to start exploit file. Good. So I'm going to try to use NC, see if it works or not. Where's my NC command? I'm trying to find my NC command here. Okay. Yeah, it works pretty good. So this is what appears within the VChat.